All right, today we're talking about what makes good science. Well, good. We're going to run what I call the experiment gauntlet. This is all about how scientists have to fight off all these hidden things that can totally mess up their results. It's how we separate a splashy headline from actual, solid proof. So, you're scrolling online and you see it. New study proves coffee boosts memory. Sounds great, right? But hold on a second. How do we really know it was the coffee? What if the people who drank coffee just happened to be more motivated that day? Or maybe they got more sleep the night before? How can we be 100% sure it was the coffee and not something else? That is the single most important question in experimental research. Because, at its core, an experiment is pretty simple. You've got one thing, the independent variable, or IV, and you want to see if it causes a change in another thing, the dependent variable, or DV. Does coffee, or IV, actually improve memory, or DV? It seems like a straight line, but the problem is it's never that clean. There are always these little gremlins, these hidden variables, trying to get in there and mess up that beautiful, simple arrow. And today, we're going to learn how science fights. So our first step on this quest for clean, trustworthy data is to identify what we're up against. You can't fight an enemy you can't see, so first we have to give these little gremlins a name. And here is their official scientific name, extraneous variables. That's just a fancy way of saying they're anything and everything that is not our independent variable, but that could still be causing a change in our results. If these guys are running wild, we can't say for sure that our coffee is what boosted memory. It could have been them. These are the hurdles in our gauntlet. Okay, so the very first challenge we've got to face in the gauntlet is a big one. It's all the unpredictable stuff that people, the actual participants, bring with them to an experiment. We call these participant variables. And just think about it for a second. Every single person who walks into a lab is completely different, right? Some are in a great mood, some are anxious, some are geniuses, some are not, some are super motivated, others are just there for the gift card. All these little differences can totally skew the data if you're not careful. And here's why it's such a disaster if you get it wrong. Let's go back to our coffee study. Imagine, just by pure chance, all the really motivated, focused, well-rested people end up in the group that gets coffee. And all the tired, anxious, easily distracted people end up in the group that doesn't get coffee. Well, your results are going to be garbage. It'll look like the coffee is a miracle drug, when really, you just had one group that was set up to win from the start. So how do scientists prevent this nightmare scenario? They use an incredibly powerful but beautifully simple tool called random allocation. It's basically what it sounds like. You get your pool of participants, and for every single person, you do something random, like flip a coin. Heads, you're in the coffee group. Tails, you're in the no coffee group. The magic of doing this is that it scrambles all those individual differences. Your motivated people, your tired people, your memory whizzes, they should all get spread out pretty evenly between the two groups. It just neutralizes the whole problem. Okay, challenge 1 is down. We figured out how to handle the variables inside the people. Now for the next trial in the gauntlet, controlling the variables outside of them. We're talking about the setting itself. These are what we call situational variables. Think about it. Was one group tested in a bright, quiet room while the other group was stuck next to some loud construction? Did the first group take the memory test in the morning when they were fresh, but the second group took it at 4 p.m. when all they could think about was going home? All of these things, lighting, noise, even the time of day, can mess with your results. And it can be ridiculously subtle. This quote really hits the nail on the head. It's not just the big stuff. Even tiny differences in how you give instructions to each group can contaminate the data. The solution here is called standardization. Researchers have to be incredibly strict. They create a script, a procedure, a setting, and it has to be identical for every single person. The only thing that should be different between the groups is the one thing you're testing. Now, let's zoom in on a really specific and really common situational problem: order effects. This is a huge issue in any study where you have people do more than one task. For example, they might just get better at the second task because they got some practice on the first one. Or they might do worse on the second task because they're just bored or tired. Either way, the order you do things in is now affecting the results. So how do we get around that one?
with a very clever technique called counterbalancing. Let's say we're testing if listening to rap music helps or hurts your memory. Instead of having everyone listen to rap first and then do the test in silence, you split your participants. Group A does the rap music condition first, then the silent one. But Group B does it in the reverse order. They get silence first, then the rap music. This way, any effects from practice or boredom get spread evenly across both conditions. And when you average the scores, those order effects just cancel each other out. It's brilliant.
All right, we've handled people, we've handled the environment. Now for the final and maybe the most fascinating part of the gauntlet, controlling for the biases and expectations inside our own heads. So first up is something called demand characteristics. Here's the thing. People are smart and they're curious. When they're in an experiment, they're constantly trying to guess, what's this really about? What are they hoping to find? And these little clues in the experiment can cause them to change their behavior to give the researcher the results they think they're supposed to give. They're not trying to cheat, they're just trying to be helpful, but it totally ruins the data. And hey, it's not just the participants. Researchers are human too. The experimenter effect is when the researcher's own hopes and biases unintentionally influence the people in their study. It could be a little subconscious smile when a participant gives a good answer, or a slightly different tone of voice. It's basically a self-fulfilling prophecy. The researcher expects to find something, and they accidentally help make it happen. And finally, we have the one you've probably heard of, the famous placebo effect. This is just the raw, incredible power of belief. If you give someone a sugar pill and tell them it's a powerful memory drug, their memory might actually get better. Not because of the pill, but because they believed it would work. Their expectation creates a real physical change, which makes it impossible to know if your actual drug is working. So, with all these psychological forces at play, participant expectations, researcher bias, the power of belief, how in the world do you get a clean result? You have to bring out the ultimate weapon in the researcher's arsenal: blinding. Blinding basically means you're strategically keeping people in the dark. In a single blind study, the participants don't know which group they're in. They don't know if they got the real coffee or the decaf placebo. That knocks out the placebo effect. But to be even more sure, you need to use the gold standard, the double-blind procedure. This is where neither the participant nor the researcher collecting the data knows who got what. That way, nobody's expectations, conscious or unconscious, can possibly get in the way. So, there you have it. We have officially made it through the gauntlet. We've tackled the people, the setting, and the biases in our own minds. Let's do a quick recap of the tools that got us through. This right here is the essential toolkit. When you're worried about the people problem, all those individual differences, you use random allocation to spread them out. When you're worried about the environment problem, the setting, you use standardization to make everything identical. When you're worried about the order problem, you use counterbalancing to mix things up. And to outsmart all those tricky psychological biases, you use blinding. It's this whole combination that gives us confidence in scientific results. So in the end, you can see that real science isn't just about having a cool idea. It's this incredibly rigorous, careful process of eliminating every other possible explanation until only the truth remains. So the next time you see that headline, don't just ask, what did they find? Ask, how did they run the gauntlet? Thanks for joining me on this explainer.